Earlier this week, we took our first look at linear equations, specifically situations where you multiply a range of different values of x all by the same number and see what comes out. For example, with the equation y equals 2x, we chose to use the numbers 1, 0, and negative 2. If we multiply 1 by 2, we of course get 2. 0 by 2, of course, gives us 0. And if we replace the letter x with negative 2, the result is negative 4. Because these are x and y numbers, we can turn them into coordinate pairs, 1, 2, 0, 0, and negative 2, negative 4. If we have the coordinate pairs, we can put those as points on a graph, and those points will create a perfectly straight line. That's why this is called a linear equation, because it creates a line. What we will be adding today is addition or subtraction at the end of the equation. So our new equation is y equals 2x plus 1. This means we can choose any number we want to stand in for the variable x, do the math, and see what comes out the other side as our y value. For example, if we decide that we are going to replace the letter x with a negative 2, then our formula becomes y equals 2 multiplied by negative 2 plus 1. And then we do our math. 2 times negative 2 is negative 4. Plus 1 gives us negative 3. So, if we put a negative 2 into our equation for x, the result on the other side is negative 3. If we put a 0 into the formula, 2 times 0 is 0, plus 1 will give us 1. And if we replace the letter x in this equation with a positive 2, 2 times 2 is 4, plus 1 equals 5. Once again, we can use these pairs of numbers to create points on a Cartesian grid. First, negative 2, negative 3, which is down here in quadrant 3. Then 0, 1, and 2, 5. Again, notice that they create a perfectly straight line. Now, the important thing to notice about this line, we haven't discussed before, is that information about the line is buried within the equation itself. Let's take a look at the slope of this line that we've created. Remember, slope is a fraction, where the top number is how far you have moved up or down, and the bottom number is how far you have moved left and right. To get from this point at negative 2, negative 3, to this point at 0, 1, we have to go up 1, 2, 3, 4 steps. And then we go to the right 2 steps. Since we went up, that's a positive 4. And since we went to the right, that's a positive 2. We can simplify 4 over 2 down to just 2. And that's important because the number 2 is right here in our formula. The number that goes in front of the x, the number that you will multiply by whenever you're doing an equation of this type, will always end up being the slope of the line that you create. Now, let's look at this point. In mathematics, the word intercept means to cross or to make connection with. This point at 0, 1 is where our created line intercepts or crosses the y-axis. Therefore, it is called the y-intercept. And that information is built into the formula as well. The y-intercept is located at 0, positive 1. And we see at the end of our formula a positive 1. There's a reason that I've made both of these yellow, because in your linear equation formula, the amount that you add or subtract will always be the second number in your y-intercept location. Your y-intercept will always be 0, comma, and then whatever this number is. This kind of formula is referred to as a slope-intercept form because the formula includes the slope in front of the x and the y-intercept in your addition and subtraction. Let's take a look at another example. This time we have the formula y equals negative 2x minus 1. We can choose any numbers that we want for the x value. In this case, I've chosen to use negative 2, 0, and 2. Let's fill out the chart for each of those values. First, let's replace the letter x with negative 2. Negative 2 multiplied by negative 2 gives you positive 4. Minus 1 is positive 3. That creates the point negative 2, 3, which we can put into our graph. What if we replace the x with the value 0? Negative 2 times 0 is 0. Minus 1 gives you negative 1. And that creates the point 0, negative 1, which we can put onto our graph as well. Finally, negative 2 multiplied by positive 2 is negative 4. Minus 1 would give you negative 5. So our third point is 2, negative 5. Again, these form a perfectly straight line. Let's look at what happens with the slope and with the y-intercept. Remember, the slope should be negative 2, because that's the number in front of the x, the number that we multiplied by, and the y-intercept should be 0, comma, negative 1, because that's what's at the end of the formula. Our slope goes down 1, 2, 3, 4. So negative 4 on top. And then 1, 2 to the right. Positive 2 on bottom. That simplifies to negative 2, which is what we predicted because that's what's in the formula. The y-intercept is located here at 0, negative 1. Which makes sense because there's a negative 1 at the end of the formula. A third example, 3x minus 2. What should be our slope is the number in front of the x, that's 3, and our y-intercept should be 0, comma, the thing at the end, negative 2. So if we put a negative 1 in, 3 times negative 1 is negative 3, minus 2 is negative 5. If we put in a 0, it's 3 times 0, minus 2 is negative 2. And if we put in a 2, 3 times 2 is 6, minus 2 is 4. The slope, 1, 2, 3 up, 1 over, which is the same as 3. And our y-intercept is at 0, negative 2, which makes sense because there's a minus 2 at the end of the formula. In your homework folder on OneNote is 14th of October, Intro to Linear Equations, homework number 1. It is due by 9 p.m. Thursday evening. A reminder that the first quarter ends tomorrow, so any outstanding or missing work needs to be turned in by midnight Friday. Have a great weekend. I'll see you on Monday.